This is an additional lesson on factoring, and it is a mixture of all the different types of factoring. This would be the replacement lesson for 5.2 if you are following along with the Algebra Nation workbook. If you wanted to write these things down while you listen to the video, I did attach a PDF copy in our class folder, so you can go ahead and print that and then watch the video if you want something to keep with you, or you can just walk through and write some things down, but that is up to you. So first of all, factoring itself, we have to understand it is reverse multiplication. The whole point of factoring in terms of, for the purpose of this course, is we're going to use factoring as a method for solving quadratic equations. We briefly spoke about how we could use factoring to help find the x-intercepts, and so that's really the goal of what we're moving to. But there are so many different types of factoring that we need to get a solid foundation of how to factor before we even start applying it to using it to finding the x-intercepts. So the first kind of factoring is just factoring out a GCF, the greatest common factor. So several factoring methods. The approach depends on the polynomial. We'll start with identifying and factoring out the greatest common factor of that polynomial. We check the coefficients for a GCF, and then we look at the variables. A variable must be present in all terms to be a GCF, and if a variable is present in all terms, take the one with the smallest exponent. You divide each term by the GCF and leave the remaining factors in parentheses. You can always check your work by distributing. So our first example that we're going to factor by GCF is number 17. If we look at the numbers first, we have 6, 14, and 10. So we will be looking for the largest number that goes evenly into all three of those, and it looks like that number is 2. And then we will look at the variables. We have a y with all three terms. We have to take out the lowest exponent, so y squared, that is the amount of y's that at least all three of them have. So we can take out a y squared. So that's the GCF. In parentheses, we're going to write what would be left when we factor that out. So to find out what's left, you can divide each factor by the GCF. So 2y squared, we're going to divide each of these by 2y squared, and then we'll find out what should be left. So if we have 6y to the fourth divided by 2y squared, that's going to leave us with 3y squared. Remember, when we divide the same base, we can subtract the exponents. Plus 7y to the first power minus 5, because the y squareds would cancel out. So this is the factored form of this trinomial. We just saw what was shared amongst the terms and pulled them out. So if you wanted to double check yourself, you could distribute it back out and see if you got the original problem, and then you would know if you factored the problem correctly or not. So question number 18, we have 12, 36, and 6, so we know that we can pull out at least a 6. A to the fifth, a to the fourth, a to the second. There's an a with all three of them, so we'll take the smallest exponent of 2. B to the second, b to the third, b to the second. So there's a b with all three terms, so we can take out a b to the second power. We will then find what's left by dividing each term by the GCF of 6a squared b squared. That's what we're doing to find what's left in the parentheses. So when we do that, our first term, what would be remaining would be 2a to the third power minus 6a to the second power b to the first power minus the 6's, a squareds, and b squareds all cancel out, but that doesn't mean there's nothing there. It was the same thing over itself, so there must be a 1 as a placeholder. Last two examples like this, 14, 28, and 14, we can take out a 14. G is with the first two terms, but not the last, so we cannot take out a G. But H is with all three of them. They all have at least an H to the first power, so we can take out just an H to the first power. If we divide everything by 14H to find what would be left, we would be left with GH, because the 14 over 14 would become a 1. You could write it, it's not necessary, plus 2G, plus, again, the same thing over itself would leave us with a 1. Last example of GCF, 18, 24, and 36. So thinking of what number goes evenly into all three, I believe it is 3. So we will take out 3. X is with the first two, but not the last one. Y is with the first and the last one, but not the middle. But Z is with all three terms, so we can take out a Z to the first power, because that's the smallest one here. So if we divide everything by 3Z, we would be left with 18 divided by 3 is 6, x squared y minus 24 divided by 3 would be 8xz plus 36 divided by 3 should be 12. And so if you ever do this to where you take out the GCF of the number, but then you notice, sorry, I went a little too fast there. That should be 12yz squared. If you do this and you notice that I did pull a GCF out, but the numbers still have a common factor, it just means you didn't pull out the greatest common factor. So technically, I can still pull out a 2 from all of these. So it means my original GCF should have really been a 6. So I'm going to make the adjustment. And if I can pull out a 6Z, that's really the GCF, and I just was moving too fast and didn't notice it. So really, what should be left if I pull out a 6Z would be 3x squared y, and then minus 4xz, and then plus 6yz squared. So that's just GCF, just looking for the common factor, taking out the highest factor that is shared by every term in that polynomial. The next kind of factoring is if you have a trinomial. Most of the time we're working with quadratics here, but if you have a trinomial and we're trying to work backwards and find which two binomials were multiplied to give us that trinomial. So if we are doing this kind where the number out front is just a 1, an understood 1, our end goal here is that we're finding two numbers that multiply to give me C and add to give me B. So that multiply to get C and add to get B. So for example, on this one, we're looking for what two factors of 12 would also give me a sum of 7. So this is a positive 12, so I know the signs on my numbers match because that's how you get a positive product. The fact that the middle term's a positive 7 means that both of them were positive. So we're looking at a 4 and a 3, a 2 and a 6, or a 12 and a 1. Out of those combinations, the numbers that multiply to give me 12, the combination that also adds to give me 7 is 4 plus 3. Because it has to multiply to give me 12 and add to give me 7. So 4 and 3 are the factors we're looking at. So using that information, we're taking this trinomial and working backwards to figure out what two binomials would be multiplied to give us that. So x squared came from x times x. And then we know that our factors were a positive 4 and a positive 3. Once we have our factors, we can use the distributive property and multiply it back out to see if we arrive at our original problem. So x times x gave us x squared. Then we have plus 4x plus 3x plus 12. Our two middle terms, 4x plus 3x, are combined because they're like terms. And so we have x squared plus 7x plus 12. So we checked our answer and it is correct. The answer to the actual problem, though, are the factors themselves, because that is what we're trying to accomplish, is figure out what factors multiplied by. So this is the solution, those two factors. This was me checking to see if my solution was correct. So a few more of these examples. For number 17 here, I would set up my two binomials. A squared came from A times A. Since 16 is negative, I know my signs must be different, because to multiply and get a negative product, that must come from opposite signs. So I'm looking for two numbers that multiply to give me a negative 16, but that add up to give me a positive 6. Now technically, because they're opposite signs, it's really a difference of positive 6. So thinking of factors of 16, we've got 16 and 1, 8 and 2, 4 and 4. Keep in mind, one of them has to be negative to get a negative 16. So which one of these, if I add together, would give me a positive 6? Well, it must be an 8 and a negative 2, because 8 plus negative 2 is what would also give me a difference of positive 6. So I've got a plus 8, because 8 is the positive, a minus 2. And again, you could multiply it back out to see if it matched, and it does. Number 18, we've got x times x to get x squared. Some combinations that multiply to give me a negative 72. We'll focus on those first. So the biggest one that jumps out to us is 9 times 8. And so keeping in mind one of those has to be negative. Seeing if there are any other combinations, 72 divided by 2, so 36 and 2. Obviously 72 and 1. 72 divided by 6 is 6 and 12. So there's several different combinations here that could multiply to give us a negative 72. Keep in mind one of these have to be negative. But which of these would have technically a difference? We can call it a sum, but they're opposite numbers. But which would have a difference of negative 14? Well, out of these combinations, it would be, it would not be any of those, so there must be another combination. So I did 72 divided by 18 and found that another combination would be 18 times 4. And so this is going to be the combination. So 18 and 4 is the combination of what would have a difference of negative 14. If my end result is negative 14, then the 18 must be what is negative and the 4 must be what is positive, because negative 18x plus 4x is what's going to leave us with the negative 14x. So we've got minus 18 plus 4. Those would be our factors. You could write them opposite, but you have to make sure the minus is with the 18 and the plus is with the 4. So number 19, we have y times y, that gives us y squared. Factors that multiply to give us a positive 40 and have a sum of 13. The end is positive here, so they must match, and this tells me that they're both positive. So I've got 4 and 10, 20 and 2. Then we've got other combinations, 8 and 5. So I think that we have found the one that also adds up to 13, because 8 plus 5 is also 13. So our factors are y plus 8 and y plus 5. Last example of a leading coefficient of 1. This time my signs match. So I know I've got W and W. My signs match. This tells me they're both going to be negatives. So I'm looking for a set of factors here that multiply to give me 48, but add up to give us a negative 16. So thinking of what we can multiply to get 48, 12 times 4 is the first one that pops in my mind, keeping in mind they're both negative. If I add together negative 12 plus negative 4, that also already gets us to negative 16, so those must be the factors that we want. If that hadn't been the first one I chose, I would list them out and see which one works. So sometimes they'll mix together multiple factoring methods, like looking for a GCF and then factoring into binomials. So if I look for a GCF first, 4, 12, and 8, 4 will go into all of them, and I'm left with k squared plus 3k plus 2. And so we're going to bring the 4 on the outside down, and we're going to break that trinomial down into two binomials. So k squared came from k times k. The factors of 2 that also add up to a positive 3 are 2 and 1. So if you just did this, that would not be the final answer. You would have to have all three of these. You'd have to have the GCF and the two factors. Again, 2, 8, and 24 shares a common factor of 2. So when we factor out the GCF of 2, we're left with x squared minus 4x minus 6. Sorry, not 6. Went too fast there. Minus 12. And so the factors of negative 12 that have a difference of negative 4, if we reason through those, I know this was x and x. These were opposite. And so I believe it would be a negative 6 and a positive 2, because that would give me negative 6x plus 2x, which would bring us back to negative 4x. So that final answer would be all three of those. So from here, the next kind of factoring is very similar, but this is when the number out front of the trinomial is not just a 1, but it's greater than 1. So when a is greater than 1. Today we talked about two different methods for that. We talked about guess and check, which always works. It just sometimes, for some of us, takes a little longer. And then we also talked about this other way where you could do the slip, factor, divide, bottoms up. It's not really the name for it, but it's really the process. So if you choose that method, you slip a to the end and multiply by c. Factor the new basic trinomial, divide both your factors by the value you slipped in step 1, and then reduce the fractions and slide any denominators up to the variable, distribute, and check. So we have this one, and we're going to try guess and check on this first one, and then we're going to try the kind of trick on example 2. So for example 1, guess and check, we learned that we know the first two terms are what multiply to give us the leading term here. So 2x squared must have come from 2x times x. That was easy because 2 is prime, and so the only combination is 2 and 1. If it had been a term that with multiple factors, we might have to check multiple combinations. Then we focus in on 3 and think of what's the possible combinations. Well, again, 3 and 1's the only possible way to get to 3 by multiplying, and so that limits it. But there are often times when the number at the end is not prime either, and you have to list out multiple factors and see which one works. So the big question here now is, do I put a 3 here and a 1 over here, or a 1 and a 3? Well, the middle term is what's going to let me know which combination is appropriate. So if I do a plus 3 and a plus 1, because I know they're both positive, because the n term's positive and the 5 is positive here. So if I do this, my check is really, the only thing I actually have to focus on is the middle term, because I just made the first and the last one work out. We know that the middle term will come from the product of 3 and x, and 2x and 1. So 3 times x will be 3x. 2x times 1 will be 2x. 3x plus 2x will give us the 5x. So if you can't just see just the middle and you have to multiply out the whole thing to check, that is fine. But we know it's going to be just those two terms that do the middle, so that's really all you have to do to check. On the other one, we're going to try this other method, which is just trying to accomplish the same thing of finding the factors. And so if I use this method, we multiply a by c. So we're going to slide the 5 down and multiply it by 6. And so we'll be left with m squared minus 17m plus 30. We will then factor this new trinomial. So we say m squared came from m times m. A positive 30 tells me my signs match, but a negative 17 tells me they were both negative. The factors of 30 that also add up to negative 17 must be a negative 15 and a negative 2. Because we multiplied by a 5 in the beginning, we have to come back and undo that, so we divide by the number we slipped down there. So we're going to divide by 5. 15 over 5 turns into 3, it reduces to 3, so m minus 3. 2/5 does not reduce into a whole number, so this is where you slide the denominator in front of the variable to get 5m minus 2. So we'll double check and make sure we did this correctly. M times 5m gives us 5m squared. Negative 3 times 5m is a negative 15m. Negative 2 times m is a negative 2m. And a negative 3 times a negative 2 is a positive 6. Negative 15 minus 2 combines to give us negative 17, so we did it correctly. So our answer is m minus 3 times 5m minus 2. You can use guess and check all day long. It always works. This is just another little trick that happens to work if you do it correctly and you remember each step. We'll do a few other examples, but this time I have to be careful because now they're mixing in GCFs. This note sheet tells us that, but eventually all of the factoring is going to be completely mixed together, and you've got to get into the habit of always looking for a GCF before trying any other kind of factoring. So on number 7, 10, 75, and 35 all share a common factor of 5 that should be pulled out before we do any other factoring. So if we take that out, we are left with 2k squared plus 75 divided by 5 is 15k plus 35 divided by 5 is 7. And so now we have to check and see if what's inside of here could also be factored any further. So we'll bring down our 5. If we do the slide method here, and I do 2 times 7, I would be trying to factor k squared plus 15k plus 14, and I would be looking for which factors of 14 that multiply for 14 add up to 15. Well, that must be k plus 14 and k plus 1. If I choose this method, I have to remember to come back and undo what we did in the beginning here, multiplying by the 2. So we have to divide both of these factors here by a 2. I'll bring down the 5 again. That's just staying on the outside because it's part of our answer. 14 over 2 will reduce to k plus 7. 1/2 does not reduce to a whole number, so the bottom goes up. And the other factor is 2k plus 1. So if we were to multiply these two back out, it will bring us to here. And if we were to multiply these two back out, it would bring us to the original. So our final answer is this piece with all the factors. It's all important. On a test, if you just gave me these two, you'd be missing part of the actual answer. So we must give all of that to get full credit. On number 8, the common factor we should pull out first is 2, and then we're left with 6x squared plus x minus 1. And so here we could again try the slide method here. So bringing down the 2, it's still part of the answer. We would then be trying to factor x squared plus x minus 6. So we're thinking, what are the two numbers that multiply to give me negative 6, but then add together to give me a positive 1? That's going to be x plus 3 and x minus 2, because that would be a positive 3x minus 2x, which would give me a positive 1x. I can't make the mistake of stopping here because I used this other method. I have to come back and divide by the 6 that we slid down. And so 3, 6, and 2, 6 do not become whole numbers, but they do reduce to 1/2 and 1/3. And so since they are still fractions, the bottom, the reduced one, needs to go up in front of the variable. So we really have 2x plus 1, and 3x plus 1. So this whole thing should be our final answer. So we'll double check our work because that was a little confusing. So we should probably check. 2x and 3x gives us 6x squared. And then we have, oh, this is what I did right here. This should be a minus. Okay, so 6x squared plus 3x minus 2x minus 1. That part brings us back to 6x squared plus x minus 1, which brought us back to here. And then if we multiplied 2 by all of that, that would bring us back to the beginning. So our actual answer here is the completely factorized version with the 2 out front, 2x plus 1, and 3x minus 1. The last type of factoring is factoring by grouping. So if you have 4 terms, you should always check for a GCF first. So if I'm looking at question number 3 here, I see 12, 2, 30, and 5. There's not a number that goes evenly into all 4. Then I have x with 3 of the terms, but not the last one, so I can't factor out an x. And so when that happens, there's a method of grouping the first 2 terms and the last 2 terms. Now, something that's important is when you group, if this happens to be negative, we should put a plus between them and keep the minus with the 30. So really what I'm looking at here is 12x cubed plus 2x squared plus negative 30x minus 5. If I keep the minus there, it's going to not necessarily make it all wrong, but it just causes you to have to be aware of something, and sometimes that causes us issues. So just a good rule of thumb is to shove the negative in there and put a plus between them. So once we did, the point of doing this is now that we can group these two together, we can pull out the common factor just of each individual parentheses. So in the first parentheses, 12 and 2, we can factor out a 2. X cubed, x squared, we can factor out an x squared. And what we'll be left with in our first parentheses is just a 6x plus 1. In the second parentheses, we can factor out a negative 5. So if we factor out a negative 5, and we can technically divide by them if we need to see what's happening here. So plus minus 5, I can just write minus 5 here. It's not that big of a deal. Negative 30x divided by negative 5 will give us a positive 6x, and negative 5 divided by negative 5 will leave us with a plus 1. So our parentheses match, which is good. That's what we usually want to see here. Since these match, they are common terms that could be factored out. So just like if this had been 2x squared y minus 5y, instead of just having this simple common term, we have an entire parentheses that happens to be the common term. So just like we would take the y out and write what's left, that's what we're going to do here. We're going to factor out the 6x plus 1. We're going to take that and set it in a parentheses out front. And then once we pull that out here, what we're left with is 2x squared and then minus 5. So you group, pull out the GCFs. If your parentheses match, you pull out the parentheses and write what would be left. So we'll do one more like that. So question 4, out of the 4 coefficients, there's not one number out of all 4 that I could pull out. There's a v with the first 3, but not the last one. So we're going to group them together, the first 2 and the last 2. Since there's a plus here, I'm safe. I don't have to watch out for that. From the first set of parentheses, I should be able to take out at least a 2. So take out a 2. V cubed, v squared, we can take out a v squared. And we'll be left with 3v minus 8. In the next parentheses, we can take out a 7. So we're going to pull out plus 7 that we pulled from the 21 and 56. And that leaves us with a 3v minus 8. Again, our parentheses match like we hope they would. So this is a common factor that can be factored out. So we will set it out front in a parentheses. And then when we factor those out, what we will have left in parentheses will be 2v squared plus 7. So those are all the different ways of factoring, and eventually it's going to get to where you see many of them at once. There's only one other kind of factoring that we're going to talk a little bit more in the future, and really it's just special cases which you could do even if you didn't recognize them. So hopefully that lesson helped you with your homework, and it is here if you need to watch it again.